Every gemstone has a color. At least, that's what most people believe. But a handful of extraordinary crystals refuse to follow that rule. Rotate them only a few degrees, and entirely different colors appear. The light hasn't changed. The gemstone hasn't changed. So, what did? Hidden deep inside these crystals is one of the rarest optical phenomena in nature, one capable of revealing colors that were always there but almost never seen. Today, we're counting down 15 of the world's most extraordinary pleochroic gemstones. Number 15, Iolite, the Viking gem that reveals hidden colors. Most gemstones look the same no matter how they're turned. Iolite is different. Rotate this remarkable crystal and its appearance changes from deep violet blue to pale gray or even yellowish tones, all under the same light. The colors aren't shifting because of reflections. They're changing because the crystal is revealing different directions of its internal structure, making Iolite one of the finest natural examples of pleochroism. This unusual optical effect begins deep within metamorphic rocks, where intense heat and pressure form the mineral known as Cordierite. Small amounts of iron inside the crystal selectively absorb polarized light depending on the viewing direction. As the gemstone is rotated, different wavelengths become visible, causing its color to change without any alteration to the lighting itself. For gem cutters, this creates a unique challenge. A slight change in how the rough crystal is oriented before cutting can dramatically affect the finished gem's color. Positioned correctly, Iolite displays a rich sapphire-like blue. Cut from the wrong direction, it can appear noticeably dull or gray. Iolite has also been linked to Viking navigation. According to a long-standing historical tradition, transparent pieces of Cordierite may have been used to help locate the hidden position of the sun through polarized light when clouds covered the sky. While historians continue to debate how widely this technique was used, the story reflects the extraordinary optical behavior that has fascinated people for centuries. Iolite offers an impressive introduction to pleochroism, but the next gemstone reveals an even more dramatic display of hidden colors, making its transformation even harder to believe. Number 14, Andalusite, the gemstone that looks like 3 different stones. Some gemstones reveal subtle color shifts. Andalusite can appear to become an entirely different gemstone. Turn it slowly under the same light and flashes of olive green, golden amber, reddish brown, and honey yellow emerge from within a single crystal. Rather than blending together, these colors often appear side by side, creating one of the most striking examples of pleochroism found in nature. This remarkable effect begins during the formation of the mineral deep within metamorphic rocks, where intense heat and pressure reshape aluminum-rich sediments over millions of years. The crystal grows with a highly ordered internal structure that interacts with polarized light in different directions. As light travels through the gemstone, certain wavelengths are absorbed while others pass through, allowing completely different colors to appear depending on the viewing angle. Unlike many famous gemstones prized for a single signature color, Andalusite is valued because no single view tells the whole story. Every slight rotation reveals another hidden side of the crystal, making each movement feel like a new discovery. Skilled gem cutters carefully study the rough before cutting, choosing an orientation that showcases as many colors as possible in a single finished stone. Most gem-quality Andalusite comes from countries such as Brazil, Sri Lanka, Spain, and Tanzania, but truly exceptional specimens displaying strong, balanced pleochroism remain uncommon. Collectors often seek stones with the most dramatic contrast, where green and warm golden tones can be seen together with remarkable clarity. If Iolite introduced the hidden world of pleochroism, Andalusite proves just how spectacular that phenomenon can become. Yet even this remarkable crystal is only the beginning, because the next gemstone produces an optical display so vivid that it has fascinated gemologists for generations. Number 13. Kunzite, the delicate crystal that changes from pink to violet. At first glance, Kunzite appears to be a soft pink gemstone known for its elegant pastel color. But rotate the crystal and a hidden transformation begins. Depending on the viewing angle, its delicate pink can deepen into violet or fade into a nearly colorless appearance, revealing a striking display of pleochroism that surprises even experienced gem collectors. Kunzite is the pink to lilac variety of the mineral spodumene, formed deep within giant granite pegmatites during the final stages of magma crystallization. Trace amounts of manganese become locked inside its crystal structure, giving the gemstone its distinctive color. Because the crystal absorbs polarized light differently along separate crystallographic directions, different colors emerge as the gemstone is viewed from different angles. This optical behavior makes Kunzite one of the most challenging gemstones to cut. Before a single facet is polished, gem cutters must carefully examine the crystal's internal orientation. A well-positioned cut can produce a vivid pink with flashes of violet, while an incorrect orientation may leave the finished gemstone looking noticeably pale and lacking the vibrant colors hidden within the rough crystal. Large gem-quality Kunzite crystals have been discovered in countries including Afghanistan, Brazil, Madagascar, Pakistan, and the United States. Although impressive specimens are not exceptionally rare, stones displaying strong color combined with pronounced pleochroism are far more desirable among collectors because they reveal the gemstone's true optical character. Kunzite proves that some of nature's most beautiful optical effects don't rely on intense colors, but on the crystal's ability to reveal different shades with every subtle movement. And the next gemstone takes that phenomenon even further, displaying one of the strongest and most celebrated examples of pleochroism ever found in the gem world. Number 12. Tanzanite. Few gemstones demonstrate pleochroism as dramatically as Tanzanite. Viewed from one direction, it displays a rich sapphire blue. Rotate the crystal, and flashes of violet emerge. Turn it again, and subtle reddish or burgundy tones begin to appear. Three distinct colors can exist within a single gemstone, making Tanzanite one of the world's most celebrated examples of strong trichroic pleochroism. This extraordinary optical behavior begins beneath the foothills of Mount Kilimanjaro in northern Tanzania, the only known commercial source of gem-quality Tanzanite. Formed around 585 million years ago during intense regional metamorphism, the gemstone is the blue-violet variety of the mineral zoisite. Trace amounts of vanadium combined with its unique crystal structure cause polarized light to be absorbed differently along three separate crystallographic directions, producing its remarkable color shifts. Because of this powerful pleochroism, cutting Tanzanite is a highly specialized skill. Every rough crystal must be carefully studied before faceting begins. A slight change in orientation can dramatically alter the stone's dominant face-up color. Expert cutters position the crystal to emphasize its prized deep blue and violet tones while minimizing less desirable brownish directions that may also exist in the rough. Tanzanite's rarity adds even more fascination. Its known deposits are confined to a relatively small mining area near Miralani Hills, making it thousands of times rarer than diamonds by geographic occurrence. Combined with its breathtaking optical properties, this exclusivity has made Tanzanite one of the most sought-after collector gemstones of the modern era. Tanzanite transforms with almost every movement, revealing colors hidden within its crystal lattice rather than on its surface. Yet, as impressive as this display may be, the next gemstone produces an even more unexpected optical surprise, one that can shift between entirely different families of color with remarkable intensity. Number 11. Benitoite, California's rare blue gem with a hidden optical secret. Benitoite is famous for its brilliant sapphire blue color, but that first impression tells only part of the story. As the gemstone is slowly rotated, the vivid blue begins to change. Depending on the viewing direction, flashes of bluish-violet and nearly colorless tones emerge from within the crystal, revealing a striking display of pleochroism that many people never notice at first glance. This rare optical effect is the result of benitoite's unique hexagonal crystal structure. As polarized light travels through the crystal along different directions, certain wavelengths are absorbed while others pass through. The gemstone doesn't generate new colors, it simply reveals different ones already hidden within its internal structure, making each viewing angle slightly different from the last. Benitoite formed millions of years ago under an unusual combination of hydrothermal activity and high-pressure geological conditions. Gem-quality crystals have been found almost exclusively in California's San Benito County, where the gemstone was first discovered in 1907. The rare geological environment required to create benitoite has made it one of the world's most geographically restricted gemstones. Its rarity presents another challenge. Most benitoite crystals are naturally small, and clean stones over 1 carat are exceptionally uncommon. Because the crystal also exhibits noticeable pleochroism, cutters must carefully orient each piece of rough to preserve its intense blue while maximizing brilliance and minimizing lighter viewing directions. Today, benitoite is treasured not only for its scarcity, but also for the subtle optical complexity hidden inside every crystal. A slight turn is enough to reveal that its famous blue is only one part of a much more intricate display of light. But even this exceptionally rare American gemstone cannot match the dramatic transformations of the next crystal, whose powerful pleochroism can make it appear as though several different gemstones exist within a single stone. Number 10. Cordierite, the original pleochroic crystal. Long before pleochroism became a scientific term, one crystal had already demonstrated the phenomenon with remarkable clarity. That crystal was Cordierite. Rotate a transparent specimen under the same light and its appearance shifts dramatically from deep blue to violet, then to pale gray or yellowish hues. Few minerals reveal the hidden relationship between crystal structure and polarized light as clearly as this one. Although Iolite is the gem-quality variety of Cordierite, examining the mineral itself reveals why it has become a classic example in mineralogy. Its orthorhombic crystal structure causes polarized light to travel differently along 3 crystallographic directions. Each direction absorbs different wavelengths, allowing multiple colors to emerge simply by changing the viewing angle rather than the lighting. Cordierite forms deep within high-grade metamorphic rocks, where aluminum-rich sediments are transformed by extreme heat and pressure over millions of years. These demanding geological conditions create crystals with the precise internal structure needed to produce strong pleochroism. Even small variations in chemical composition can influence the strength and balance of the colors that eventually appear. Because of these optical properties, Cordierite has become an important reference mineral in gemological education. Students frequently study it with a dichroscope to observe pleochroism directly, making it one of the best natural examples for understanding how polarized light interacts with anisotropic crystals. While gem-quality Cordierite is admired for its beauty, its greatest significance lies in what it reveals about the science of gemstones. It shows that color is not always a fixed characteristic of a mineral, but can change dramatically depending on the direction in which the crystal is observed. And if Cordierite explains the science behind pleochroism, the next gemstone pushes that phenomenon even further, producing richer colors and one of the most dramatic optical displays found in the natural world. Number 9. Sillimanite, the forgotten gem that reveals hidden colors. Sillimanite is rarely mentioned alongside the world's most famous gemstones, yet its optical behavior makes it one of the most fascinating minerals for anyone studying pleochroism. At first, it may appear to display a simple greenish, yellow, or brown color, but as the crystal is rotated, entirely different shades emerge, revealing that its appearance depends not only on the light itself, but on the direction from which the crystal is viewed. This remarkable transformation is caused by Sillimanite's orthorhombic crystal structure. As polarized light passes through the crystal along different crystallographic axes, certain wavelengths are absorbed while others are transmitted. The result is a gemstone capable of displaying noticeably different colors from different viewing angles, a textbook example of pleochroism in action. Sillimanite forms under extreme temperatures during regional metamorphism, when aluminum-rich rocks are subjected to immense heat deep within Earth's crust. It belongs to the same mineral group as Andalusite and kyanite, yet each develops under different pressure and temperature conditions. These differences create distinct crystal structures, giving every member of the group its own unique optical character. Gem-quality Sillimanite is found in countries including Sri Lanka, India, Myanmar, Brazil, and Madagascar. Transparent crystals suitable for faceting are uncommon, making fine specimens especially attractive to collectors who appreciate rare optical phenomena rather than mainstream jewelry stones. Although Sillimanite remains one of the least familiar gemstones on this list, its ability to reveal multiple hidden colors reminds us that some of nature's most remarkable optical effects are often found in the gemstones few people ever notice. Yet even Sillimanite's impressive pleochroism is overshadowed by the next gemstone, whose dramatic shifts in color have earned it a reputation as one of the most visually captivating optical wonders in the gem world. Number 8. Diaspore, the gemstone that seems to transform before your eyes. Some gemstones reveal subtle changes as they are turned. Diaspore can appear to transform completely. Viewed from one direction, it may display soft green tones. Rotate the crystal, and flashes of champagne, golden yellow, or delicate pinkish hues begin to emerge. These shifting colors are the result of strong pleochroism, allowing a single gemstone to present multiple appearances without changing the lighting. Diaspore is a rare aluminum hydroxide mineral that forms under specific hydrothermal and metamorphic conditions over millions of years. Its monoclinic crystal structure interacts with polarized light in different directions, selectively absorbing certain wavelengths while transmitting others. As the viewing angle changes, different colors become visible, creating one of the most elegant pleochroic displays found in natural gemstones. Because of this pronounced optical behavior, cutting diaspore requires exceptional precision. Every rough crystal must be carefully examined before faceting begins. Even a slight change in orientation can dramatically influence the gemstone's final appearance, determining which colors become most visible when viewed face up. The finest stones are cut to reveal a balanced combination of their naturally shifting hues. Gem-quality diaspore is exceptionally uncommon, with the most famous faceting material coming from Turkey. The limited availability of transparent crystals combined with their remarkable optical properties has made high-quality specimens highly desirable among collectors and gem enthusiasts seeking something beyond traditional precious stones. Diaspore proves that pleochroism can create an almost living display of color, with every movement revealing another hidden side of the crystal. But the next gemstone produces an even stronger optical performance, displaying vivid color shifts so dramatic that it has become one of the most celebrated pleochroic minerals ever discovered. Number 7. Axinite, the copper-brown crystal with extraordinary pleochroism. Axinite may not have the fame of sapphire or emerald, but few gemstones display pleochroism with such striking intensity. At one angle, the crystal appears rich brown with coppery warmth. Turn it slowly and shades of violet, reddish-brown, honey yellow, or smoky gray begin to emerge. Instead of reflecting different colors from its surface, Axinite reveals them from deep within its crystal structure, making every movement uncover another hidden layer. This remarkable optical effect comes from Axinite's triclinic crystal structure, one of the most complex among gemstone minerals. As polarized light passes through the crystal along different directions, different wavelengths are absorbed, allowing multiple colors to appear depending on the viewing angle. The result is a gemstone whose appearance constantly changes, even while the lighting remains exactly the same. Axinite forms in contact metamorphic environments, where hot mineral-rich fluids interact with surrounding rocks near cooling magma bodies. These unusual geological conditions produce sharply formed wedge-shaped crystals, a distinctive feature that makes Axinite instantly recognizable to mineral collectors. Transparent crystals suitable for faceting, however, are far less common. Gem-quality Axinite has been discovered in countries including Pakistan, France, Mexico, Russia, the United States, and Tanzania. The finest specimens combine excellent transparency with strong pleochroism, creating gemstones that reveal multiple warm colors as they are viewed from different directions. Although Axinite remains unfamiliar to many jewelry buyers, it has earned lasting respect among gemologists for its exceptional optical behavior. It demonstrates that some of the strongest examples of pleochroism are found not in the world's most famous gemstones, but in those rarely seen outside specialized collections. Yet even Axinite's remarkable display is surpassed by the next gemstone, whose brilliant blue crystal conceals an even more fascinating play of hidden colors beneath its surface. Number 6. Blue sapphire. Blue sapphire is celebrated around the world for its rich, velvety blue color. Yet beneath that familiar appearance lies an optical secret many people never notice. When the crystal is viewed from different directions, its color can shift from deep royal blue to violet blue or lighter greenish blue. These subtle but measurable changes are the result of pleochroism, revealing that even one of history's most famous gemstones possesses hidden colors. This phenomenon is created by sapphire's trigonal crystal structure. As polarized light travels through the crystal along different crystallographic directions, certain wavelengths are absorbed more strongly than others. The gemstone itself does not change color. Instead, different viewing angles reveal different components of the light already contained within the crystal. The strength of this effect varies from one sapphire to another. Stones with higher clarity and richer color often display more noticeable pleochroism, while others show only subtle differences. Gemologists frequently use a microscope to observe these hidden color directions, making pleochroism an important feature in gemstone identification and evaluation. For gem cutters, sapphire presents a careful balancing act. Before faceting begins, each rough crystal is examined to determine its optical orientation. A slight adjustment in the cutting direction can significantly influence the finished gem's face-up color, helping maximize the prized deep blue that has made sapphire one of the world's most valuable gemstones for centuries. Major sources of fine blue sapphire include Sri Lanka, Myanmar, Madagascar, Australia, and the famed deposits of Kashmir, whose exceptional stones have become legendary among collectors. Despite their different origins, all share the same fundamental optical behavior that quietly reveals itself as the crystal is turned. Blue sapphire proves that even the world's most recognizable gemstones still hold hidden scientific wonders beneath their surface. But the next gemstone displays an even more dramatic optical transformation, revealing colors so distinct that they can appear to belong to entirely different gems. Number 5. Ruby, the crimson gem with a hidden optical dimension. Ruby is admired for its intense red color, a symbol of power and royalty for thousands of years. But beneath that famous crimson glow lies an optical characteristic that often goes unnoticed. Rotate a natural ruby under the same light, and subtle shifts between deep purplish red, vivid crimson, and slightly orangey red can become visible. While less dramatic than some gemstones on this list, these changes are a genuine result of pleochroism, adding another layer of complexity to one of the world's most celebrated gems. Like sapphire, ruby is a variety of the mineral corundum. Its trigonal crystal structure causes polarized light to travel differently along separate crystallographic directions. Trace amounts of chromium, the element responsible for ruby's red color, absorb light differently depending on the viewing angle. As the crystal is rotated, different shades of red are revealed without any change in the light source. Although the effect is usually subtle, it plays an important role in gem cutting. Before faceting begins, cutters carefully examine the crystal's optical orientation to position the strongest and most desirable red toward the top of the finished gemstone. Even a small change in orientation can influence the richness and uniformity of the final color. Some of the world's finest rubies come from Myanmar's Mogok Valley, Mozambique, Madagascar, Vietnam, and Tanzania. Regardless of their origin, every natural ruby shares the same fundamental crystal structure that makes pleochroism possible, even if its intensity varies from one stone to another. Ruby reminds us that pleochroism is not always dramatic. Sometimes its beauty lies in the subtle differences that only become visible through careful observation, revealing the extraordinary precision hidden within a natural crystal. Yet even the legendary ruby cannot match the remarkable optical display of the next gemstone, whose vivid color changes are so pronounced that they have become one of the defining characteristics of the entire. Number 4. Tourmaline. No gemstone family showcases pleochroism quite like tourmaline. A single crystal can display dramatically different colors simply by being viewed from another direction. One angle may reveal a rich green or deep blue, while another uncovers lighter yellowish green, olive, or brownish tones. The light hasn't changed. The crystal has simply exposed another side of its internal optical structure. This remarkable phenomenon comes from tourmaline's trigonal crystal system and its complex chemical composition. Elements such as iron, manganese, and chromium become incorporated into the crystal as it forms, influencing how polarized light is absorbed along different crystallographic directions. As the gemstone is rotated, different wavelengths dominate, producing distinct colors from different viewing angles and making tourmaline one of the strongest naturally pleochroic gemstones. The intensity of pleochroism varies across the tourmaline family. Blue indicalite, green verdolite, and red rubellite are especially well known for displaying noticeable color differences, with some crystals showing dramatic contrast between their darkest and lightest directions. This optical complexity is one reason why tourmaline continues to fascinate gemologists as much as jewelry collectors. For gem cutters, orientation is everything. Before cutting begins, each rough crystal is carefully examined to determine the direction that will best display its most desirable color. A poorly oriented cut can leave a vibrant crystal looking noticeably darker or duller, while an expertly cut stone reveals the full beauty hidden within its crystal lattice. Tourmaline deposits are found across Brazil, Afghanistan, Nigeria, Madagascar, Mozambique, Pakistan, and the United States. Yet regardless of where it forms, every natural tourmaline tells the same scientific story, a crystal capable of revealing different colors simply because light travels through it in different directions. Tourmaline demonstrates that pleochroism is not a rare curiosity, but one of the defining characteristics of an entire gemstone family. Even so, the three gemstones ahead produce optical effects so extraordinary that they have become legendary among gemologists and collectors alike. Number 3. Alexandrite. Alexandrite is famous for changing from green in daylight to red under incandescent light, but hidden behind that legendary phenomenon is another remarkable optical property. Rotate a natural alexandrite under the same light, and subtle shifts between green, bluish-green, and yellowish-green, or between purplish-red and reddish tones under warm lighting can also appear. While its color change effect is its defining characteristic, alexandrite also exhibits genuine pleochroism, making it one of the most optically complex gemstones ever discovered. These two phenomena are often confused, but they are not the same. The dramatic color change is caused by different light sources containing different wavelengths of light. Pleochroism, however, occurs because alexandrite's orthorhombic crystal structure absorbs polarized light differently along separate crystallographic directions. Even without changing the light source, rotating the crystal can reveal different shades hidden within the same gemstone. Alexandrite forms under exceptionally rare geological conditions where chromium and beryllium, elements that rarely occur together, become incorporated into the same crystal during its growth. This unlikely combination is one reason why fine alexandrite is considered among the rarest and most valuable gemstones in the world. Because alexandrite displays both strong color change and noticeable pleochroism, cutting the rough crystal requires extraordinary precision. Every orientation is carefully studied to preserve the finest balance of color while maximizing the gemstone's optical performance. A small mistake during cutting can reduce the intensity of both effects. Important deposits have been found in Russia, Brazil, Sri Lanka, Tanzania, and Madagascar, but exceptional gem-quality alexandrite remains extremely scarce. The finest stones are prized not only for their rarity, but for the extraordinary way they interact with light from every direction. Alexandrite proves that a single gemstone can possess multiple optical wonders at once. Yet the two gemstones still ahead display some of the strongest and most spectacular examples of pleochroism in the natural world, where changing the viewing angle alone creates an unforgettable transformation. Number 2. Topaz. Topaz is often admired for its exceptional clarity and brilliant transparency, but beneath its polished surface lies an optical phenomenon that many people never realize exists. Rotate a natural crystal under the same light and its color can shift noticeably depending on the viewing direction. Blue topaz may reveal lighter and deeper blue tones, while imperial and yellow varieties can display golden, orange, and pinkish hues. These changes are not reflections. They are the result of strong pleochroism hidden within the crystal itself. Topaz belongs to the orthorhombic crystal system, meaning polarized light travels through it differently along separate crystallographic axes. As the crystal selectively absorbs certain wavelengths while transmitting others, different colors become visible simply by changing the viewing angle. The lighting remains exactly the same, yet the gemstone presents a different appearance with each subtle rotation. This optical behavior makes topaz especially demanding during the cutting process. Before the first facet is placed, gem cutters carefully examine the rough crystal to identify the direction that best displays its strongest and most attractive color. An incorrect orientation can leave the finished gemstone looking noticeably lighter, reducing the visual impact that the rough crystal originally possessed. Gem-quality topaz is found in Brazil, Pakistan, Russia, Sri Lanka, Nigeria, and several other parts of the world. Among these sources, Brazil is particularly famous for producing exceptional imperial topaz, whose naturally warm colors become even more captivating when combined with the gemstone's pleochroic properties. Although topaz is often associated with brilliance and transparency, its hidden ability to reveal different colors from different directions makes it far more complex than it first appears. It stands as one of the finest demonstrations of how crystal structure alone can transform the way light is perceived. But even topaz cannot surpass the extraordinary gemstone waiting at number 1, a crystal whose exceptionally strong pleochroism and extreme rarity have made it one of the most remarkable optical treasures ever discovered. Number 1. Painite. For decades, painite was considered the rarest gemstone on Earth. So few crystals had ever been found that many gemologists knew it only from scientific journals rather than museum collections. Yet beyond its legendary rarity lies another remarkable secret. Rotate a transparent painite crystal under the same light, and its appearance changes dramatically. Deep reddish-brown tones can shift toward orange-red or subtle greenish hues, revealing one of the strongest pleochroic displays found in any natural gemstone. This extraordinary optical behavior is rooted in painite's unique crystal structure. As polarized light travels through different crystallographic directions, specific wavelengths are absorbed while others pass through. The gemstone itself never changes color. Instead, each viewing angle reveals a different part of the crystal's hidden optical character, making every slight movement uncover another layer of color. Painite formed under an exceptionally rare combination of geological conditions requiring elements that seldom occur together in the same environment. That unlikely chemistry explains why the mineral remained virtually unknown for much of the 20th century. Although additional deposits have since been discovered in Myanmar, fine transparent gem-quality crystals remain exceptionally uncommon, and high-quality faceted specimens are still among the most sought after by collectors. Its powerful pleochroism also presents a major challenge for gem cutters. Every crystal must be studied with great precision before faceting begins. The orientation of the cut determines which colors will dominate the finished gemstone, making careful planning essential to reveal the crystal's full optical potential. Painite perfectly captures the theme of this countdown. It demonstrates that a gemstone's true beauty is not always defined by a single color, but by the remarkable way its internal crystal structure interacts with polarized light. Every rotation tells a different story, revealing colors that were hidden only moments before. From the subtle elegance of Iolite to the extraordinary complexity of Painite, these 15 gemstones reveal that some of nature's greatest masterpieces cannot be appreciated from a single angle. Their changing colors are not illusions or tricks of the light, but visible evidence of the extraordinary crystal structures created deep within the earth over millions of years. They remind us that in the world of gemstones, sometimes the most breathtaking discoveries appear only after looking at the same crystal from a completely different perspective. What makes pleochroic gemstones so extraordinary isn't simply that they display different colors. It's that those colors have always been there, hidden within the crystal, waiting to be revealed from a different angle. Each rotation offers a glimpse into the remarkable way nature shapes light deep inside the earth over millions of years. From the subtle beauty of Iolite to the exceptional rarity of Painite, these 15 gemstones remind us that some of the greatest geological wonders aren't immediately visible. They reward those willing to look a little closer. If you enjoyed this documentary, don't forget to subscribe for more premium videos exploring the science, history, and hidden stories behind the world's most fascinating gemstones. And in the comments below, let everyone know which pleochroic gemstone impressed you the most and whether you've ever seen one in person. Thanks for watching, and we'll see you in the next documentary.